So we're given just the diagram here, which we're going to use. And I'm going to find something I'm going to call C, which is going to be the one couple that's equivalent to applying all 6 of these forces. Again, we're talking externally equivalent, which in the future, when I say equivalent, everything is external. All right, so I'm going to have my initial diagram here where I'll just copy all of the forces that I have acting. The 300 Newton pair are 5 meters apart. We have a 400 Newton pair. And those are 2 meters apart. And the 200 Newton pair is 0.2. And the idea here is we can draw just a single couple acting on our system that we can call C. I'm arbitrarily assuming the direction of C. I could turn out to be wrong. I'm going to assume that the one couple is going to be acting in a counterclockwise manner, which we would call a positive couple. But it could turn out in the end that that's not the case. So going from 6 forces to a single couple is what we want to do here. And this is only the case that we'll be able to simplify it this far because every force is paired with an equal and opposite one. So one pair at a time, we can start to simplify and see what's the couple or the moment contribution due to that particular pair of forces. So I'm going to start with just what I'll call C1 here, which is going to be the moment or the couple caused by the I start with the 300 Newton pair. The order I start in doesn't really matter. So I have a 300 up, I have a 300 down, so they are the same magnitude, and they're in opposite directions. One's in the positive y, and one's in the negative y. So this 300 Newton pair forms a couple, because again, those 2 rules apply. They're equal magnitudes, but opposite directions. So the equivalent couple to these acting is going to be the magnitude of the force, which is 300. And we multiply that by the distance, the perpendicular distance between these 2 forces. Now this one is set up nicely for us because they're in the y direction, so their perpendicular distance is going to be how far apart in the x direction they're located. So in this case, they're 5 meters apart. Their perpendicular distance is 5 meters. When we're in 2D, like we did last week on Monday, looking at those 2D moment equations or moment problems, we have to go back to thinking about, is this going to cause a clockwise or a counterclockwise twist? Because our z direction is coming out of the board. So from the 300 Newton pair, is that going to be twisting, would that twist our object clockwise around z or counterclockwise around z? Right, so from this, our object, if we picture if it could spin, if it weren't connected to the wall there, just due to these 2 forces, ignoring everything else, if we were to apply these 2 forces, this object would want to spin clockwise around the z direction. Remember, in 2 dimensions, clockwise is negative. So we manually, in 2 dimensions, when we use the scalar approach, have to say, is it clockwise or counterclockwise? Meaning, is it negative or is it positive? So the couple caused by this pair of forces is negative 1,500, and that's newtons times meters. Right. Separate from that, we have a twisting by I did the 400 ones next. Again, they are the same magnitude. One is in the positive y, one's in the negative y, so they're going to simplify. We can simplify them to a couple. Their magnitude is 400. Their perpendicular distance apart is the 2 meters. Ignoring all the other forces, if we were just to twist it or apply these two forces on this beam, what direction would the beam want to spin? Right? If we did this, we would want to spin counterclockwise, so this is going to be a positive value for the couple. So we're going to get a positive 800 Newton meter contribution from the 400 Newton couple. Right, finally, the 200, their magnitude is 200 newtons. Now, in this case, we have one in the positive x direction, one in the negative x direction. So we want to take their vertical distance apart, or the vertical distance is the perpendicular distance of 0.2. And we see here that if these were the only forces acting on the beam, it would want to be twisting in a clockwise rotation. So this is also going to be negative. So the moment contribution, or the couple, due to the 200 Newton pair is a negative 40 Newton meters. But we want to simplify this down. This is if we reduce each of them individually into a couple, C1, C2, and C3. But we can add all of those couples together to get the net effect of all 6 of these forces, or all 3 pairs of these forces acting. So all we do is, to simplify all 3 of our couples, we just have to add them together. So the net effect of all of these acting at the same time, negative 1500 plus 800 minus 40, the net effect is a negative 740 Newton meter couple.